Hi guys, welcome to 06.02 Comparing Data Sets. So it says your school is raising money for a new mascot costume. To help raise funds, you want to sign up 3 companies to advertise at one of the 3 school events: basketball/football games, school dances, or concert/plays. The total attendance at the different events is basically the same. What would be the best for each? So first you mail, so car dealership, we have a computer store, a clothing store, and then the car dealership said they want the with the least overall change in events. Clothing store wants the greatest average attendance, and then the mall wants the greatest typical attendance. So we're going to look at the data and talk about a couple of different ways that we can determine what's going to be best for what these companies want. So here's the data. It has the totals across the bottom. Okay, and then which of the 3 activities is most suitable for each of the 3 advertisers? So as we go through the lesson, we're going to talk about the different types of statistical ways or methods to determine these kinds of things, what they mean, and how to use them. So along with the ways that we talked about showing data in the previous lesson, this is a way to show data called a box plot. So a box plot divides a list of data into 4 sections called quartiles. The plot is a data display that shows the minimum, lower quartile, median, upper quartile, and maximum of the data set. Each quartile has 25%, or 1/4, of the data points in it. A box plot can be used as part of the statistical process to analyze and interpret data. So the lower quartile we call Q1 or quartile 1. Upper quartile we call Q3 or quartile 3. And then as you can see in each of these different little sections of the box plot, we have 25%, which add up to the total data, which would be 100%. There are 5 pieces of information shown on the box plot. Together, these 5 pieces of information create the box plot. We call that the 5-number summary. In this example, we're going to take a look at how to create this 5-number summary. So we have pineapple pizzas made by a small pizza shop during 1 week, in no specific order here, but what we really want to do is change the order to make it from least to greatest whenever we're analyzing data. So at the bottom of the screen, you can see that they're the same numbers but ordered from least to greatest. The first number in a 5-number summary is the minimum. Very self-explanatory. It is the smallest value in all of your numbers, which is why it helps going from least to greatest. Then we have the lower quartile. I like to do the lower and the upper quartile last, and I'll show you when I do an example later, but the lower quartile is the median or middle of the lower half of the data. So you do not want to include the median when you are calculating the lower quartile and that Q1 value, and it is the median of the lower half of the data. I'll show you how to do that in just a moment. The median, you should remember hopefully from middle school when you guys were talking about data, that's just the middle. The upper quartile is going to be the upper part of the data, the upper half of the values, but it's the median of the upper half. So it's the middle of the upper half of the data. And then the maximum, self-explanatory, that is the highest or the largest value in your data. After we find all these values, we just put them together in a 5-number summary. So I'm going to go ahead and write out the values and show you how I would personally do the 5-number summary. I don't go in order, I kind of skip around a little bit. So the minimum is definitely 3. We see that. The maximum is going to be 14. So I find those 2 first. And then I want to find the middle, the median. So what you can do is you can take each end and you can count in the same amount. So 3, 14, 4, 11, 6, 10, and we get to 8 in the middle. Now for the lower quartile or Q1, we do not want to include the median, so I'm going to kind of create these lines to split the data, and the middle of that data is my Q1. So in between 3 to 6 is 4. If I do the same on the other half, the median of that data is going to be my upper quartile or Q3, and that's my 5-number summary. So I do the minimum, maximum, median first. Those are the easier ones. And then I do my Q1 and my Q3. Now, I'm going to create a box plot. So kind of like a dot plot in the last lesson, you only want enough space for your minimum to your maximum. You don't really need anything else. I'm just going to go 2 and then 15, so 1 below, 1 above. And I'm going to space this out, kind of labeling with 5 and 10. So my minimum goes at the end with the line 3, my maximum at 14, and then I'm going to do my Q1, which is at 4. I'm going to do my median, which is at 8, and then I'm going to do my Q3, which is at 11. Now the 3 inner lines get boxed around, and then I get 2 lines, one to the minimum, one to the maximum. In previous years, you may have learned about this as a box and whisker plot, but we just simplify it and call it a box plot. So here's a different set of data, and the box plot is already created for us, but we're actually going to go through and find our 5 number summary. So the first thing I want to do is I want to take all of these numbers that you see in parentheses, and I want to order them from least to greatest. So what I like to do is I start with the lowest number, and then as I go, I cross them out so I know I already used that number. So 2, 3, 6, 10, or sorry, 2, 3, 6, 8, then 10, and then I have 14, 15, 16, and then it looks like I'm going to have 18, and then 22 is going to be the last one. So after I have all of my numbers written out, I'm going to go ahead and do my 5 number summary. My minimum is 2, it's pretty obvious. My maximum is 22, as you can see. For the median, I'm going to go in from both sides, so let's go 2, 3, 6, 8, 10. That's 5 spaces. I'm going to go 5 spaces in from the right, that gets me to 14. Now, when you're stuck in between two numbers, you need to find the middle of those two numbers, or the average. So 10 plus 14 divided by 2 is going to be 12, or right in between 10 and 14 is going to be 12. Now, I do not want to include the median when I split my numbers. 10 and 14 are not the median, so I can actually include those in my little brackets, and then I'm going to find the middle of each of those. So 6 is in the middle on the left side, 16 is in the middle on the right side. So 6 is going to be my Q1, and then 16 is going to be my Q3. On the left, they already have the corresponding box plot drawn for us, and if you line up the lines that they made, it's exactly the numbers that we found at 2, 6, 12, 16, and then at 22 to round out the 5 number summary. So now it says look back at the school attendance data, what information can be determined. I'm just going to click on the box plots instead of making them. That's going to take quite a bit of time. And as you can see, all the box plots look pretty different. And it's going to make sense because obviously the data is different. And you're going to see this arm, I guess you can call it the maximum, going all the way out to about 850. And that's kind of what we call an outlier. This 850 data point is so far away from the rest of the data, the central area of the data, that we can definitely call that an outlier. And then that middle line, I'm kind of up at the top, that's called the median. So in the middle of your box is always going to be your median. At the end of your box is going to be your minimum. At the right side of your box is your maximum. And then you have your Q1 and your Q3 as well. Now we're going to look at some example problems. So what fraction of data points are found in each quartile? Well, you want to think a quarter. Quarter is 25%. So that's definitely going to be 25%, or a fourth. So you can also write that as 1 over 4 because it asks for what fraction, so I'm going to go with a fourth. Many times, knowing the shape of the data set and how it's distributed is a measure of central tendency, can provide vital information about the data and what is the best method for analysis. So example number 2 says which data has the largest range. So if we take a look back at the data, it's going to be dances because you go from 850 to 125. Range is going to be your largest number to your smallest number, subtracting them. So dances definitely has the largest range. If I look at concerts and plays, we go from, well, that should be 440 to 125. Whoops, guys, I made a mistake when I was doing that. It's not 250, but basketball, football games goes from 395 to 150, which is 245. So the largest range is dances. The smallest range is definitely going to be basketball slash football games, because I did make a mistake with the concerts and plays. That should be 440 minus 125 for that one. All right, so which data has the narrowest interquartile range? So that's kind of a new term we haven't heard of before. Interquartile means between the quartiles. So from quarter 3 to quarter 1, what is the value there? So essentially all we would do is take quarter 3 and subtract quarter 1. Um, and then it says which data has the widest IQR. So again, we would look at quarter 1 and quarter 3 and see which one is going to be the widest. All right, many times knowing the shape of a data set or how it's distributed around its measure of central tendency can provide vital information. If a set of data is symmetrical, then each side of the data is like a mirror image around the measure of center. If a data set is asymmetrical, then the two sides will not be mirror images of each other. So you could see on the symmetrical side that it looks very typical. my data is going up and it's coming down. If I were to fold that in half, it's going to be the same on both sides, hence calling it symmetrical. We also think of that as like the standard for data in a way. And then asymmetrical, as you can see, one side of the data is way further off than the other. We do have an outlier in this one. In looking at the school activities data, which activity seems to be the least symmetrical? So in the fourth quartile would be much wider or longer than the other three for school dances. What makes the quartile so wide? The maximum value is 850. So this is going to be an outlier. It's going to be way far away from the other data points. The type of measure of central tendency is used to analyze can depend on the type, shape, and spread of the data set. The spread of the data can help you decide which measurement is most appropriate. So looking back to the school activities data, which set appears to be spread most evenly? You would have to go back and look at the box plots. That's definitely going to be our basketball and football games. If you were to take a knife or whatever and cut it in half, it's going to be the same on both sides. This implies that the mean or the average of the data would be very close to the median. So mean and median are two different ways that we can analyze the central tendency. If we have an outlier, this tends to pull the mean value even higher or lower. So you would have to kind of imagine if you have everybody in the class that's somewhere around 5 feet tall and then someone 7 feet tall, that's going to skew the data. It's going to pull it higher because the person who's 7 feet tall. Example 6. Can you tell by the box plot for the school which have the highest and lowest means, why or why not? It would seem very likely that dances has the highest mean because its Q3 value of about 450 is high or is above the high end of the ranges of the other two data sets. So it's all the values are kind of higher. But the mean cannot be determined for sure from the box plot. So the mean is the average. So if I take data set 4 data sets, so data plus data plus data plus data divided by 4, I can't really determine that from a box plot because the box plot just shows the 5 number summary. It doesn't tell me how many data points are in what area, what the numbers are. I don't know exactly, so it's hard for me to determine what the average is going to be if I don't know the exact numbers. So let's say I have a box plot and I draw it out and it's just going to be random, no numbers attached to it. There's my minimum, there's my interquartile range in the middle, and there's my maximum all the way out here. I don't know what numbers are included here. I don't know if I have a couple in here, if I have just the one outlier all the way at the end. I don't know, so I can't tell the mean from a box plot. Example 7 says find the mean and the median of each. So in order to find the mean, like we were just talking about, that's the average. I'm going to take the total and divide it by how many I have. So the total is there, 2,195. I'm going to divide this one by 7. I get 313. For my dances, I'm going to divide this by 6. I get 365 for a mean. And then I'm going to take 2,200 for this total and divide it by 8. If you count it out, we get 274 for the mean here. Now for the median, I know the data is not in least to greatest order, but I'm just going to look for the lowest and the highest and cross them out simultaneously, one from each end. So one low, one high, one low, one high. I get a median here of 360. And then for dances, I'm going to cross off one low, one high, one low, one high until I get in between two numbers. So I have two numbers left. I have 300 and 280. I have to find the middle between those numbers. That's going to be 290. And then same thing for the last one. I'm going to take one low, one high, one low, one high until it looks like I'm going to get to two numbers left, which is going to be 250 and 285. And then the average between those two numbers is going to give me my median, which is going to end up being 267.5. So my means and my medians are there listed for you. Now something that you may have noticed is that when I have an even number of data points, then I'm left with two numbers at the end for the median and I have to divide to find the average, or add then divide. If it's an odd number of data points, then my median is going to be exactly one of the values that I have there. So when I had 7 points, it was an exact data point for my median. When I had 6 and then 8, I had to find the average between two. So here are my answers, exactly what I had. Except for 274. I guess I didn't round that when I found the average when I divided that, but they rounded it up to 275. If a data set is grossly unsymmetrical or contains outliers, the median is a good choice as a measure of central tendency. If the data is fairly symmetrical and contains no suspected outliers, then the mean is the best choice. So whenever you have data that's really skewed or asymmetrical, that means you're going to have outliers and you're going to want to use the median as your measure of central tendency. And then if you have symmetrical, which is like standard, you're going to use the mean for that. Now, when we're talking about spread in a box plot, so how can box plots show spread in distribution? Well, you can see the range on the graph for minimum and maximum values. Box plots also show what is called the interquartile range, or IQR, and we talked about that a little bit earlier. This is the difference between the upper and lower quartile, and it is the box shape on the graph. So you'll see here, Q1 to Q3, that distance or that amount in the middle is the IQR. It shows how the middle 50% varies. You made a number of observations about the data sets for the school activities. You use mean and median to measure the center of the data and use the IQR to measure the spread. Now you'll explore what it means to use standard deviation of the data to make observations. You made a number of observations. Oh, I already read that. Have you heard of standard poodles, standard voltage, standard hourly range? A standard is a measure that sets an expected value for what is normal or expected. So standard deviation, we're talking about standard data when we're using the mean. Standard deviation is a measure of spread that uses the mean of the data. The mean can be considered the standard value in a data set, and standard deviation can be defined as the distance from normal. So we have a normal distribution and we use standard deviation. The standard deviation is represented by the Greek letter sigma. You can see that little kind of O with a little flick at the top. Standard deviation can be found using technology. If you have it, we're not going to need to know how to calculate that by hand, but you can definitely click that link if you need to. The larger the standard deviation, the more spread out the data. The smaller the standard deviation, the closer the data points are. A standard deviation of 1 tells you that most of the data points are only within 1 unit from the mean. A standard deviation of 10 tells you that most of the data points are within 10 units of the mean. So that's what standard deviation tells us. For example, number 1, given the data set here, the same one that we used earlier, and knowing that the standard deviation is a measure of how is spread out the data are from the mean, what can you infer about the data with a standard deviation of 6.31? So the first thing I'm doing here is listing out my data points from least to greatest like we did before, and I want to find the mean. So what I got to do is I'm going to take all these, add them up, and then I want to divide by 4, 5, 6, 7, 8, 9, 10, because it looks like there's 10 data points. What I get after doing that is going to be 11.4. So my mean is 11.4 and the standard deviation is 6.31. So all of my data points are either going to be 6.31 above 11.4, which is my mean, or below. So I'm going to add 6.31 to my mean, and then I'm going to subtract 6.31 to my mean. So that means the data points in between these values from 6 to 16 is 1 standard deviation away from the mean. So here they show us again the data from before with the different school attendance data, and it says, which activity do you expect to have the largest and smallest standard deviations? Well, standard deviation is a measure of spread, so I'm going to look at how spread out the data is. Dances is very spread out, so I'm going to guess that the dances is going to have the largest standard deviation. Games is super small. The data is not really very spread out, so it's going to be the smallest standard deviation, or the smallest mean as well. So also if I look at the mean at the top in that table, it tells me which one's the largest and which one's the smallest. So check your answer. The largest is dances, so we were right. And then the smallest is going to be games. It indicates that it has a smaller or a smallest or the smaller of the 3 for standard deviation. Alright, so example number 3, Mrs. Smith's students made scores of those points for their Module 6 test. Based on these scores, would you expect a large or a small standard deviation? So I'm actually going to do some work here. It doesn't ask us, it asks us just to say based on these scores, what do we think? But what I'm going to do first is I'm going to number these from least to greatest, so starting with 75, and then it looks like we end up at 100. And I have my minimum, 75, I have my maximum, which is 100. And just for fun, I'm going to find the median in the middle there, so 4 points from each side. In between 85 and 90 is going to get me a median of 87.5. I'm also going to calculate the mean, so I'm going to go ahead and add up all of these numbers together and then divide them by 8. because I have 8 data points. So all of that added together and divided by 8 is going to get me a mean of 87.8 approximately if we round it. Also, what you can see is that all the data only goes from 97 to 100. That's a really small grouped together tight data set, if I can really describe it that way. So my standard deviation is going to be pretty small because all my data points to begin with weren't very spread out. They were actually pretty tight together, ranging only from 75 to 100. Choosing a measure of spread or center. When data has outliers, the interquartile range and median are usually better measures of spread and center compared to the standard deviation and the mean. It's because the outliers pull, so like I was talking about with everyone being 5 feet tall and then one person is all of a sudden 7 feet tall, it's going to pull your data up. So when your data is symmetrical and you want to use a mean and standard deviation, when it's asymmetrical and you have an outlier, for example, you're going to want to use the median and the interquartile range. So here is our try it section. So we have a bunch of data, and the first try it says make a box plot. Okay, so bear with me as I go through this. But we got a lot of numbers. We got the year and then total car and truck sales in the US. So as you can see there, towards the end there in the earlier years, it's kind of in order, but not really, as we can kind of see the data is decreasing for sure for the sales in the US in millions. By the time we get to 2009, it kind of increases again. So I'm going to start by numbering these from least to greatest. So when I'm looking at this, all through all the numbers, it looks like 10.6 is my lowest, and then we go 11.8, and as I go, you'll see a strategy that I use. I'm just going to cross them out as I go, and then 13, and then 13.5, and then it looks like 14.8, so all of those in the early 2000s, and then skip down to 16.5, and then 17. Looks like I have two of those in 2003 and then 2000, so I'm going to write 17 twice. And then it looks like I have 17.1, 17.3, and at this point the decimals weren't really working for me, so I'm just, that says point, but it's not 174, but you get the point. And then 17.5 and then 17.8. So I know my minimum is 10.6, my maximum is 17.8. To spare you some of the time and frustration, the median, if I count in the same amount from the left and I count in the same amount from the right, I end up with the two 17s there, or right in between the 17s, and 17 and 17 is going to give me 17 if I find the middle between the two. So my median is 17. And since it's in between those two numbers, to cap it, I want to draw my little brackets by the 17s there, and quartile 1 is going to be the middle of the lower half of the data, so 13.5, and then quartile 3 is going to be the middle of the upper half of the data, so 17.4. Now I also took the time to calculate the mean, so I actually added up all those numbers together and divided by however many there were, and the mean is about 15.6. Okay, so if I look at the check your answer, the mean is 15.6. They thankfully did the box plot for us because I was not about to draw that, but you'll notice that it looks like there's potentially a little outlier there at 10.6 because most of the data is to the right. You'll see our box there, our interquartile range Q1 and Q3. It says estimate the IQR. Well, I know it's Q3 minus Q1, so I'm just going to subtract 17.4 minus 13.5, and that's going to get me an IQR of about 3.9. Question 3, are there any suspected outliers? Well, we were just looking at the box plot and I was saying how 10.6 looked super kind of far away from the data, so it's a possible outlier. We had a pretty close data point, which was 11.8, so I wouldn't say it was like super super far away, but it was still, it's a possible outlier. Is the standard deviation or the IQR the best measure of spread? Well, that depends on if you think there's an outlier or not. If the data was pretty symmetrical, I would go ahead and say use standard deviation. Now, the data does look kind of skewed, so I'm going to go with the median being the best because of that possible outlier. So even if you think you might have an outlier, the best route to go is to use the median and then use the IQR because that's going to give you a better measure of spread than using the mean. So again, when your data is normal and symmetrical, use the mean. If not, use the median. Now that we talked about mean, standard deviation, median, IQR, all the different ways to look at and compare the data, I can go back to the question that we had at the beginning of the lesson, which was which activity, whether it concert, play, dance, basketball, football, those groups, which would be better for what each of these companies want. So the car dealership wanted the least overall change. Now, data that doesn't change would have a very low spread in the data, meaning the activity would need a low IQR and a low standard deviation. That would be my basketball slash football. Now, for the computer store, they wanted the highest average. Now, average is mean of the data, so I'm going to look for the highest mean, which was school dances. And then the clothing store wanted the highest typical attendance. So typical attendance is going to be the median, the middle, so you don't really care about the ends, but typically what would happen, and that is going to be concert slash plays. So now there's a little bit of data here at the bottom about a PE class. You have number of students in 11th grade and number of students in 12th grades and their average hours of exercise. So you have to be careful. For example, it says 0 hours of exercise, there's 7 students. So if we were to list this out, we would have to write 0 7 times. And then for grade 12, it was 2 zeros. So I would have to write 0 0. And then there was 4 1s. So 1 1 1 1. And you get the point. Now, for time's sake, I'm definitely not going to write out this data, nor am I going to make the box plot because that's going to take a lot of time. We're just going to look at the answers that they have and see if we can answer the questions that they have as well. So it says using technology as well. If we had graphing calculators or something, some other kind of program, that would make a lot more sense for us because this is a lot of data to do by hand. Now, can you do it by hand? Absolutely. You just have to pay attention to how many numbers you're putting down, but it's still going to take a long time to do it by hand. So here's the information that they have. We have lows of 0, high of 20 for grade 11, and then a high of 9. We have our Q1, our Q3, our median, our mean, the IQR, and the standard deviation. So everything that we could do by hand in about 30 minutes is here for us already, so we're not going to take the time to do that. Part 2 says compare the data by making box plots, either by hand on a graphing calculator or software. Here are the two box plots. So you can definitely tell, like we talked about before, you have this outlier of 20 for grade 11 all the way out. Grade 12 looks pretty symmetrical in its data. If I were to cut that in half, it would be pretty close. Grade 11 definitely not because we have that outlier. Here's our interquartile range. Now part 3 says what are the best statistics to measure spread and center. So grade 11 not symmetrical at all. I would definitely go with IQR in the median because I have that outlier. Grade 12 we said was pretty symmetrical, so I'm going to use standard deviation and mean. So that's how you're going to know which one to use because of the way it's spread out in your box plot or in the data. So here's another try it. Again, I'm not going to write all this data out. That's going to be like an hour long for this video, so I'm just going to go through what they have. It says compare the IQR, standard deviation, mean, median, and box plots for the 3 categories and choose the best measures. So if I look at the box plots that they have in the data, for college graduate, I'm going to immediately notice that there is an outlier out there. It looks like my high for this is going to be 88,000 if I look up a little bit. High school graduate, I'm going to say that's pretty symmetrical, and then did not complete high school. I'm going to say that's pretty symmetrical as well. So for college graduate, I would go with median and the IQR, and then the other two I would go with standard deviation. And for the sake of this video not being a million years long, I'm not going to go through the activities. Those are pretty self-explanatory when you look through them, but whenever your data is basically symmetrical, you want to use standard deviation and mean. If it's asymmetrical and you have an outlier, you want to use median and your IQR. Just remember that fact, how to do your 5-number summary. As always, guys, if you have any questions, please let me know, message me, send me a message on Remind, whatever you need to do to finish out strong. We only have 2 more things after this assignment, and we are done with the work for this year. So keep it up. A lot of you are doing great, and let me know if you guys need anything. Thanks.